Hey everyone, we're the Additive Group with members Atul, Elizabeth, Sean, and Mark, and this is our final project.
The main tool we are using for our project is spaCy for its ease of use and its wide selection of pre-trained language models. In addition, the TextAC plugin to spaCy helps us extract subject-verb-object triples from each sentence. We're also utilizing Neural Coref for its quick and intelligence coreference resolution, and a pared-down version of BERT for perplexity-based filtering of questions. For both our question asking and answering pipeline, we first split the article into simple sentence phrases by removing any coordinating conjunctions and the preceding commas. We then tokenized the article and did named entity recognition and dependency parsing with spaCy's large language model before using Neural Coref's large coreference model to do coreference resolution. Additionally, we computed sentence vectors for all sentences in the article and stored them for a quick reference. For question generation, we started off by coming up with general question templates and filling in the blanks using recognized named entities with the correct types. Here are some examples of the templates we used. One problem was that the questions generated were not guaranteed to have answers in the article. The first two templates produced such questions, so we ended up not using them. However, the relationship questions produced the highest quality questions using noun phrases from related sentences.
We split preprocessed sentences and the linking verb is. We extracted the pattern A is B and attempted to create a database with all the A's and all the B's. The idea was to use the A's and B's that were originally paired together to make questions whose answer is yes, and combine A's and B's that were not originally together to make questions whose answers were no. We ended up not using the database because it generated too many nonsensical questions.
For more general questions, the question word depends on the type of subject or object name entity in the question. Therefore, we created a dictionary mapping name entity types onto their corresponding question words. For example, location would map to where. For unknown name entity types, we back up to the question word what, as it is always valid. SVO questions are generated by extracting subject-verb-object triples and rearranging them to give us questions concerning the subject or object. These questions are guaranteed to be answerable, and thanks to us extending the root to include entire subject and object phrases, these questions contains a lot of context from the corpus, which makes them really interesting. Besides, we ensured correct grammar by morphologically changing the verb to fit the question, and we countered noise of the SVO extractor via strict question filtering. Unfortunately, SVO questions were unable to make use of all named entities. Certain name entities are usually not considered part of the subject or object of a sentence, so we are limited in generating questions about them. For example, dates are usually found in prepositional phrases as the object of the preposition, and so we cannot generate a lot of date questions with this approach. We tried to fix this problem by engineering our own SVO recognizer from part of speech tags and parse trees, but had little success.
This is our special feature. We generated questions that combined context from multiple sentences. We found two sentences with the same subject and created a question about that subject. We asked questions of the form question word followed by first verb and first object, and then an and then the second verb with the second object. This is an interesting type of question to answer since it requires context from beyond one sentence.
For question evaluation and filtering, we created an automatic grader for the questions we generate by using a BERT language model to evaluate each question's score. This way we can prune out questions which don't make much sense. Specific types of question generation strategies result in poor quality of questions. Therefore, we designed thresholds for each type of question generated. For example, our relationship questions tended to have higher scores than our SVO questions. If we had set only one filter threshold for both types of questions, we would only output relationship questions. By setting separate thresholds, we preserve variety. Some types of generation strategies tended to generate more questions than others, so we soft-capped each type of question generated to ensure that our final result evenly contained all types of questions.
This was a method to answer yes and no questions. We generated a list of yes or no question words, such as is, are, does, and compared the first word of a question to this list to determine whether it is, in fact, a yes or no question. To answer the yes or no question, we checked if the named entity or subject of the question occurs with the object of the question in the same sentence. We also checked the parity of the negations. We realized that there were many different ways another team could ask a yes or no question. They could ask it in the form of like true, false, or yes or no, or just have an is at the beginning of a sentence. So we figured it'd be safer to just return the most relevant sentence, and that technique will be explained more on the next slide.
Our first step in question answering is to remove the question word from the question, so we can more accurately compare sentence vectors with sentences in the article. Then we look for the top 4 sentences in the article that have the most similar sentence vectors with the question vector, and break ties by selecting the sentence with the most vocabulary overlap with the question. We did this because sentence embeddings are not perfect, and the top embeddings could be really close. In this case, the vocabulary is a great tiebreaker. In addition to finding the 4 most relevant sentences, we decided to compare the named entities from the question to the named entities in the relevant sentences. To avoid being fooled by synonyms for named entities in the question, we check if each named entity in the question has a synonym, as defined by a similar word vector to a named entity in the relevant sentence. Thank you for listening to this final project presentation by the Additive Group.